are you? Hope you are doing great and everything is well. So this is a small lab about VLAN and inter-VLAN routing. Okay, we are trying to deploy VLAN configuration. So here we are starting with a simple topology contains 4 PCs as shown and 3 switches and one integrated service router ISR 4321. Okay, the 2 PCs in red zones or red circles are in VLAN 10, and the two PCs in blue circle are in VLAN 20. And we have to do this configuration to assure that at first, without routing, PCs in the red VLAN doesn't have to communicate with PCs in blue VLAN. Okay, and after enter VLAN routing, PCs in red VLAN should be able to ping the PCs in the blue VLAN. Okay, so we need to implement the 2 main steps to understand the VLAN concept. The first step is basic VLAN configuration on the 3 switches. Okay, and the second step is inter VLAN routing using a router on a stack approach. Okay, beginning with the first part, VLAN configuration on switch 1 and switch 2 and switch 3. Okay, so we write enable or en because we can use abbreviations on switches configuration, conf t or configure terminal. Okay, we have at first in configuration of VLANs we have to create the VLANs. So we have 2 VLANs, VLAN 10 and VLAN 20, and their character or description is red or blue. I want to use a description here, okay, for ease of use only. So VLAN 10 and VLAN 10 is created, exit VLAN 20 and VLAN 20 is created. Okay, so I have now to assign the interfaces or a specific link connections on switch port interfaces. How to do this? Okay, define the access link and the trunk links. So we here have 2 access links as we see, because the switch are connected to 2 PCs, so the links on this PCs must be accessed and assigned a specific VLAN, and the link between 2 switches, here is this switch and this switch, must be trunk. Okay, exit interface fast Ethernet 0 2. So fast Ethernet 02 goes to the red VLAN. So we have to switch port mode to access at first. Switch port mode access. So this interface F02 or fast Ethernet 02 is now access. Okay, and we have to assign a specific VLAN. Switch access VLAN and the VLAN number. We said that VLAN red are 10. Okay, exit. The same for the another device in the blue VLAN. Okay, interface fast 03, switch port mode access, switch port access VLAN 20. For this VLAN, blue VLAN 20. Okay, and for the trunk link, if we see here the light are turning to orange, resetting the connection and establishing the connection again. Okay, so as we are changing the link operation, okay, after a specific time this orange light will be green light like here. Okay, continuing with the trunk link, interface fast 01, switch port mode trunk. Why trunk? Because this is a connection between 2 switches, so it have to be trunk. Now, as we see, line protocol interface fast Ethernet 01 changes state to down. Why it changes state to down? Because in trunk operation on a link, the two pairs of the link here on the switch and this switch must be defined to be trunk. I have defined the trunk in here in this side, in left hand side only. I didn't define the trunk here, so we have to define the trunk on the another switch to make the connection. Okay, as we see, by default, all the VLANs are allowed on the trunk. Okay, so in this state, VLAN 10 and VLAN 20 are allowed on this interface. To access this interface, interface fast01, and I can define the allowed VLAN also, like switch port trunk allowed VLANs, and I will write down 10 and 20. Okay, I don't use it, I won't use it for now. Okay, the second switch here, this switch is connected to two switches and router, so we have to make all the connection on this switch trunk, because it is not connected to an end device, it's only connected to a network device. Okay, and enable conf t interface. I can use here a specific methodology, interface range. Okay, but I will define each interface alone. Interface fast01, switchboard mode trunk. Okay, so look now, it's green. Okay, interface fast02, switchboard mode trunk. It's lying down like what happened in the last switch. Interface fast03, switchboard mode trunk. Exit. Okay, on the switch, enable configure terminal. Okay, without creating a VLANs or on this switch, I use the end to end methodology, so I have to create the VLANs on this switch. Sorry for not creating the VLANs. VLAN 10 and VLAN 20. Exit. VLAN 10 and 20 are created. Okay, okay, exit. Enable conf t. Okay, VLAN 10 created, VLAN 20 created. Okay, interface fast01, fast01 is connected to the device in red zone in VLAN 10, so switch port mode access as is an end device, switch port access VLAN 10. Okay, okay, fast03, switch port mode access as it is a connection between network device and the end device, switch port access VLAN 20. Okay, exit. For the connection between the two switches, interface fast02, switch port mode trunk. Okay, now these devices here, the PC and the BCR, is assigned to the same VLAN, and here the blue and the blue is assigned to the same VLAN. We try to ping now. Okay, let's see the IP here, 10.4. Okay, the ping here shall be successful. Ping 192.168.1 before. Okay, it's working. And if I try to ping the device in the another VLAN, it doesn't connect, even if it is in the same switch, like this. 20.3. Okay, 23. Okay, it is not pinging, so the VLAN is working. Then, how to make this ping successful? Defining an inter VLAN methodologies. What is inter VLAN? Okay, we have here this topology, a router on stack topology. This topology will divide the physical interface giga 0333 of the router ISR integrated service router 4321 to two sub interfaces. Okay, and each sub interface will act as a gateway for those VLANs, for VLAN 10 and VLAN 20, the red VLAN or VLAN blue. Okay, and then it will be routed. So how it does operate? Okay, at first we go here on the router. No, we don't use setup wizard for initial configuration. Enable configure terminal interface giga 000. We have to perform no shutdown to open the interface we are working on. Okay, exit the interface giga 000.10. so we are dividing the giga 000 interface, physical interface, to sub interface, not physical, sub interface. Okay, and we have to enable encapsulation. We know that VLANs encapsulate the data, and the data are tagged by a protocol called 802.1q. So we have to enable and allow encapsulation. So encapsulation dot 1q 10 for this VLAN 10. Okay, and we will assign an IP address like it is our original physical interface, 192.168.1.10.1, and the subnet mask 255.255.255.255.0. Okay, no shutdown to open the interface. Exit. For the second interface giga 00020. Okay, and we have to enable encapsulation for the tagged frames using tagging 20, number of the VLAN. Okay, and we will assign the interface IP address 192.168.20.1 255.255.255.0. Okay, no shutdown. Exit. The device in the red VLAN must be able to ping any device in any VLAN, so it's in red and blue. Okay, let's see. Okay, sorry, I have to fast forward the time. The first ping is down because of the ARP protocol, and the other pings are on. So I hope you enjoyed the video, and I hope for and I'm looking forward for your feedback, Mr. Ahmed. Thank you.